How do you secure the dispatcher? Dispatcher is the security perimeter for publish. There are several layers. First of all, filter rules. Start with deny star, then allow specific paths or extensions or methods. Block slash apps slash etc slash system slash bin slash live slash var crx slash de webdav from public. Next is block dangerous selectors and extensions such as .json, .infinity, .json, .feed, .tidy, .json should be denied by default. Whitelist only specific non endpoints. Why are we doing this is we don't want the attackers to have the information about all endpoints except for the known endpoints. Now if we are doing .infinity .json, that is going to give a very big JSON file recursively for every path in our system basically, and .tidy.json is going to give that JSON file in a human readable format. Now the third method is HTTP method filters only allow get, head and post where needed. Post is given for the form filling, and block, put, delete and options from public. The fourth one is disable WebDAV and CRXDE on publish entirely in production. Fifth one is security headers at Apache level. These security headers include strict transport security for adding HTTPS, X-frame options, content dash security dash policy, X dash content dash type dash options. Now the next sixth one is run AEM security checklist and the dispatcher SDK validated pre-deploy. And the seventh one is rate limiting at Apache through mod rate limit or upstream WAF. Now let me explain with regards to the HTTP method filters. You need to allow get, head, post only where needed, and we have to block, put, delete and options. So if you think about it, get and head are read only and safe to allow broadly for content paths. Post is needed for forms, GraphQL queries and search submissions, but only on specific endpoints, not site-wide. Put and delete map directly to Sling's repository write operations. Sling's post servlet accept these methods to create, modify or delete JCR nodes over HTTP. If exposed to public, an attacker can write arbitrary content to your repository. There is no production reason for public clients to send, put or delete. And options is the CORS pre-flight method. It's not directly dangerous, but it leaks the full list of allowed methods on each endpoint. Now, the next where we said about the disabling of WebDAV and CRX/DE on publish. WebDAV is a protocol that lets client mount the JCR as a remote file system and read or write content with standard tools. AEM enables it by default on CRX/repository. On publish, this is a direct path to repository compromise. An attacker with WebDAV access can browse, download, modify or delete any content. There is no or zero production use for WebDAV on a public publish instance. CRX/DE Lite is the in-browser repository editor at CRX/DE. Developers use it locally to inspect JCR nodes and edit properties. On publish in production, it's a graphical attack interface. An attacker who finds it can browse the repository tree visually, look at ACL, which is access control list, and probe for misconfigurations. Adobe's hardening checklist requires it disabled on production publish. Both are disabled by removing the OSGI bundles or filtering the URLs at dispatcher or both. On AEM as a cloud service, these are disabled by default in the production tier. On AEM 6.5, you must do it yourself. Now with regards to the security headers at Apache level, we need to apply it at Apache level so that they are applied to every response regardless of what AEM returns. When we talk about strict transport security, it tells the browser always use HTTPS for this domain even if the user requests HTTP. It prevents downgrade attacks where an attacker on the network forces an HTTP connection and steals session cookies. Without it, the first request to your site on a public Wi-Fi can be intercepted. Now, X-frame options are the modern content dash security dash policy frame ancestor prevents your pages from being rendered inside iframe on another site. Without it, an attacker can iframe your login page and overlay invisible buttons. Click jacking. The user thinks they are clicking a game button, but they are actually approving a transfer on your site. Now, CSP is the big one, which is content security policy. It tells the browser which sources of JS, CSS images and fonts are allowed to load. Without CSP, if an attacker injects a script source equal to evil.com into a page even briefly through XSS, the browser executes it. With CSP, the browser blocks the load because evil.com is not on the whitelist or the allow list. CSP is your second line of defense if HTML escaping fails. Now let's talk about the X content type options. No sniff. It stops the browser from guessing the content type of a response. Without it, an attacker who uploads a file your server labels as text slash plain but starts with script can sometimes get the browser to execute it as JavaScript. With no sniff, the browser respects the declared content type and refuses to execute mismatched content. Now, running AEM security checklist and the dispatcher SDK validator pre-deploy. AEM security checklist is Adobe's published list of hardening steps such as disable default users, rotate the admin password, remove sample content, lock down ACLs on slash content, disable CRX slash DE on publish. It exists because AEM ships with developer friendly defaults that are dangerous in production. Running through it pre-deploy catches regressions where someone re-enables something for debugging and forgets to undo it. The dispatcher SDK validator parses your dispatcher.ini or AEM as a cloud services modular config before deployment and flags syntax errors, missing required sections and known anti-patterns like a filter rule that's too permissive or a cache config that does not deny by default. Running it pre-deploy means broken or insecure dispatcher configs never reach production. On AEM as a cloud service, Cloud Manager runs this automatically and rejects the deploy if validation fails. On AEM 6.5, you wire it into your CI pipeline yourself. The principle behind both security checks belong in CI, not in human review. Humans miss things, pipelines don't. Now coming to rate limiting at Apache through mod rate limit or upstream WAF. Rate limiting caps the number of requests per second from a single IP or session. Without it, three threats: brute force login attacks, cache bypass, denial of service, scraping and reconnaissance. Okay, so in talking about brute force login attack, an attacker scripts thousands of password attempts per minute against live slash granite slash core slash content slash login dot html. Rate limiting blocks the IP after n failed attempts and protects accounts even if passwords are weak. Cache bypass, denial of service. An attacker sends millions of requests to URLs they know aren't cacheable. Search queries, dynamic endpoints, query strings with significant params. Each one hits publish. Without rate limiting, a single attacker with a small botnet can take down publish. Scraping and reconnaissance. An attacker enumerates your content tree by hitting .json endpoints, walking from slash content down. Rate limiting slows them enough to detect and block. Mod rate limit is Apache's built-in module. It caps bandwidth per connection. It's basic but free. Mod underscore QUS or mod underscore security are more sophisticated Apache modules that rate limit by IP, session or URL pattern. Upstream WAF, CloudFront with AWS WAF, Azure Front Door slash Akamai does this at the edge before traffic ever hits dispatcher. Preferred for production because it absorbs attack traffic without using your origin's resources. The principle is AEM Publish is your most expensive resource per request. Anything you can do at Apache or the edge to reduce load on Publish, that is caching, rate limiting, WAF rules, directly translates to capacity and uptime under attack.